Okay, hello everyone, and welcome to the first session of our Beginners Python course at Warwick Data Science Society. So I'm incredibly excited to start off the second wave of this course, and I hope that you're looking forward to learning a bit more about Python and how you can use it for your work. So I'm Tim, I'm the current president of Warwick Data Science Society. I am the author of this course and will be teaching the sessions at least for the first part of it. That said though, the actual running and arrangement of this course has been a joint effort by many people. And so that is our mentors, our subject masters, and our education officer. So a massive thank you to them too. So there are two ways that you can take part in this course. The first is just to watch these videos independent of the society. These videos will all be going up on YouTube and will be staying up there indefinitely. And so you can work through them by yourselves, and all the resources will be linked in the description. We would, however, advise that you take part in this course through the society. And by doing this, you get access to mentorship and more guidance in how you learn and tackle the questions and homework in this course. We'll also be giving out certification to people that complete it and do all of the homeworks. So if you want to get involved in actually taking the course with the society, we should be running this every term. And so if it's near the start of a term, check out our socials. You might be able to join in late. Otherwise, if it's towards the end of a term, just hang on till next term. You should be able to get involved then as well. So I'm not going to go into any major details about the course, how it's ran, or what sort of resources are available. If you're watching this course separate to the society, have a look in the description for the course website. The majority of details are there. And if you're watching this course, taking part in this course through the society, we'll have a look in the Teams group that you've been added to, and more information will be there. If you are taking this course as part of the society, your main port of call is your mentor. If there's any issues that they can't solve, they will forward them to the education officer, who should be able to handle those. And so even though I am teaching these sessions, I'm probably not going to be the most responsive, so those are the people that you want to ask about any questions. So with that, I'm going to introduce the content of this first session. And so we have quite a bit to get through, just so we can leave you knowing enough to actually solve some interesting problems. So stick with it for this first one, and hopefully we can relax a bit more with the pace in the future sessions. So we're going to look at 4 things in this session. The first is setting up this thing called Google Colab. I'll introduce that in a moment. We're then going to learn about printing. That's Python's way of talking to us and giving us output. We'll then learn how to use Python as a sort of calculator to do arithmetic. And then we'll have a look at these things called variables and the different types that variables can have. And think of these as the memory in Python, getting it to remember things for us to use later. So with that, we'll get into the main content of today's session. So the first section of today's session is all about Google Colab, what it is and how we can use it. So Google Colab is an online interactive Python editor. So basically a way we can write Python code and run it all in the cloud. And that means we don't have to install anything or set anything up on our own computer. It's very simple. Just go to a browser, type your code in, and it runs completely hassle-free. And so this course has been designed around using Google Colab. So all of our resources can be accessed on Colab, so you can get started really quickly without having to worry about getting things set up on your own computer. And so to get started on Google Colab, you can either follow this link here or just search for Google Colab in your browser, and preferably use Google Chrome. It's a Google product and it works the most stably in the Chrome browser. And so you can use Colab for free, an unlimited amount. All you need is a Google account. So if you have one already, you can sign in with that. Otherwise, you can create one specifically for this purpose. It's completely free. And so once you have a Colab account, if you open Colab up and sign in, you'll be greeted with something like this. So this shows a list of my notebooks. You can think of notebooks as the documents that exist on Colab. So you would use a Word document for writing text, and we use a notebook for writing Python code on Google Colab. And so here's some of my previously listed ones. If you're new to Colab, you won't have any of these, but what you're most likely going to want to do is to click New Notebook to create a new one. And so once we do this, we're greeted with this interface here. If we look at the top right here, if this says connect, we want to click on that to connect to one of the computational resources on Google's servers. So basically connect up to a processor to run our code. And once we've done that, we'll have something that looks like this, and we're all good to go. So that's how you would use Google Colab if you're working on your own project. But the way we're going to do things within this course is slightly different. So that's the notes I mentioned there. You've got to click connect if that doesn't display, and then that will get things started. Okay, so in this course, we're going to be working with Google Colab documents, but those are going to be provided for you with some blanks for you to fill in. And so that way you're not completely by yourself, you're filling in a template to give you a bit of a head start. And so all of these resources are going to be linked on the course webpage. And if you're watching on YouTube, you can find this in the description. If you're in Teams, taking part in the course internally, then you can find a link in there. And so the course webpage looks something like this. And if you scroll down a bit to quick access to resources, all of the presentations, recordings, templates and homeworks are going to be listed here once each session goes live. And so the thing you're going to care about for this section is the templates. So these are documents that we're going to have some gaps in for you to fill your code in and kind of follow along with the presentation and the exercises we're going to have during this session. And so if you open that up, the link will be there when you come to it. You'll have something like this. Let me just clear that. Okay, so it looks something like this here. And so as we can see, we alternate between kind of text blocks and then these kind of slightly grey blocks, which are called code blocks. And so, yeah, these are referred to as blocks or cells. It's the same terminology. And think of these as the smallest units that make up a notebook. So you can have text cells or code cells where you write your code. And so running code in Google Colab is as simple as writing it in a code cell and then clicking the play button to run it. So we're going to type some code here. It's going to be print hello world. I'll explain what this means in a second. For now, just copy this exactly as it is. Paying attention to capitalization and all the details there. And once you've typed that in, if you click the play button, Python's going to run that code. It might bring up a prompt saying, are you sure you want to run this? The answer is yes, you do. And so you click play, that's going to be ran, and we get the output below the cell there. So it says, hello world. And so a shortcut we can use there, if you're tired of clicking the play button, is Control and Enter. That's just a shortcut for that. Okay, so we'll pause for a moment to have a go at that. If you're watching the YouTube video, you'll have to pause for yourself. And if you're in one of our live sessions, well, then it will be paused for you and you can have a chance to have a go at that. If there's any questions, ask the person running that session. So we'll join back in a second. Okay, so hopefully you managed to write and get that code running just fine. Well, now we'll have a look into what exactly that code meant. Okay, so let's start with some motivation. In 8 weeks' time, hopefully when we're all Python whizzes, we'll be wanting to do 3 main things with our code. So the first is to input things. So that could be input directly from a user, could be from a dataset, could be from the web, but basically getting stuff into our Python code. We then want to actually do some computation to take our inputs, manipulate it, process it, and transform it into a new form. And then the final thing we want to do is to output something back to the user. That could be some text, it could be a visualization, a graphic, could be an animation, whatever. And so there's 3 key components. And we're going to start by looking at the last of those, so outputting information to the user, just because that's the simplest. And so one way of outputting is to do this thing called printing. And so printing is Python's way of talking back to us. And so in the last example where we printed out hello world, that was a way of getting Python to say hello world to us. And that's just a classic example of the first line of code people write in various different languages. Hello world's the canonical first line of code you write. And so we can get Python to say anything we want just by writing it as a sentence and putting it inside of the print command. So We use this print command. Yes, let's actually have a look at here. So we have the print command. This is saying we want to print something out. We want to output something to the user. And then we have to write this with correct capitalization. So capitalization matters. No capital P here. It's all lowercase. And then we follow this by brackets. And inside of the brackets, we kind of say how we want Python to print something. So in this case, we're saying, I want you to print out hello world. We're kind of giving it an input for how it should run the print command. And so we have to put that input using double quotes. And that's to let Python know this is text data. Because computers are really literal in the way they do things. And so if we didn't specify, hey, this is text data, Python's going to get very confused. So we use these double quotes to explicitly say, hey, this is text data, make sure you understand that. Okay, so that's what we write there. And that's going to let us print out any text. We could put anything inside those double quotes, and that will print out whatever we write there. And so we can also use this print function, this print command, to perform arithmetic, so to do maths. And all we have to do there is to replace that input, that text inside of quotes, with a number or some mathematical expression we want Python to evaluate. So we could put in a single number or maybe some maths formula that we want it to calculate. And the important thing here is that we don't need quotes. Quotes we use because we were putting in text data. We're now putting in numeric data, and so we don't need to tell Python, hey, this is text, by using quotes. And so 2 examples here. We can simply print out a number, so print the number 5. Again, no quotes, we're dealing with numeric data now. Or we could have a mathematical expression, a calculation. So 5 times, we use the asterisk for times, by 10 is 50. And so Python will calculate this and then print out the answer of 50. So we're already doing the sort of computations you could do on your calculator, just in Python. And so we can also get Python to print out multiple things in one go. So we mentioned the things in the brackets are kind of the inputs, the options, the way that Python should print. And so we can put multiple inputs into the print command separated by commas. And then Python will print each of these one by one, separated by a space between each input. And so, for example, we could print out some text. So I can print this and also a calculation. Then a comma after the quote to separate those 2 inputs. And our second input is going to be a mathematical expression to calculate. So Python prints the first one as normal. It then puts a space between the 2 inputs, and it's going to evaluate this one. Python goes, oh yeah, this is a mathematical expression. You probably want me to calculate that. And so it does, and gives you 15.5. And so as we can see from this example, we can combine text data and numeric data together in a print, separated by a comma. Python has no issue with that. But the important thing is, text data has quotes around it to let Python know, and numeric data doesn't because it's not text. Okay, so we're now going to pause to have a look at some puzzles, just to have a go at applying the stuff we just learnt. You can fill these out in the template. So those examples we had there, so printing the number 5, the number 5 and 10, those are also in the template. You're welcome to fill these in as you go through, but it might be better just to follow the session, just kind of pay attention to that, and then come back to these later when you want a review of this material. So what we're going to look at now is the puzzles. So in this standard puzzle section, you can fill out your answers here. And so we have some main puzzles here if you just want to follow along, or if you're finishing early or want to kind of go ahead even further, you can have a look at these bonuses here. But these are not going to be relevant for anything later in the session, so don't worry if you don't get around to finishing those. So if you're watching on YouTube, you can pause now, and we'll come back in a second to see the solutions. If you're in one of our hybrid live sessions, then it will be paused for you. If there's any questions, ask the person running that session. So I'll see you back in a moment. Okay, so hopefully you've had a chance to work through those puzzles. We're now going to have a look at the solutions to those. So the first one asked us to print out your name. So in this case, I've used an example as a name. And so I've used the print command, and then inside of my brackets, I put in an example in quotes. And again, text data, we need the quotes. The next one was to print out your three favorite colors. So I've chosen blue, yellow, and gray, the colors of the Python logo, of course. And so I put these as three different inputs to print. Print will take 1, 2, an infinite number of inputs. That's completely fine. The important thing is we separate each of those by a comma. And then when Python goes to print, it will separate each input by a space. So the next one was to calculate this expression here. So 26 times 66, add 13, and we get this answer here. And no quotes here because it's not text data. And then we see here how to do division. So we have 6804, and then we divide that by 162. So a / for division. And so the solutions here are only for the main exercises. If you want to see these solutions for the bonus ones, have a look at the filled-in template, which has all of these solutions, or you can follow the link in the presentation here. Okay, so we're now going to have a look at these things called variables. And so variables are a way of storing information for later use in our code. So essentially, think of these as a way of giving Python memory. It can remember things for us to use later. And so a variable is essentially a way of giving a name to a certain bit of data, a certain value, so that we can reference it later. And so we create a variable using the equal symbol. And I want to really highlight the point here that even though we're using the equal symbol, this does not mean the same thing as equals in mathematics. And I explain in more detail what it means as we go through. So I guess I'll explain it now actually. So what the equals means is take the thing on the left and use that as a name for the data on the right. Or another way of saying that is take the data on the right and assign that to the name on the left. So basically now, name is synonymous, means the same thing as the data David. And so whenever we use name in our code, Python will go, okay, I understand what you mean there, you mean David. And in a similar way, the second line is going to take the number 24 and assign that to the name, to the variable age. And so now age is synonymous with the data 24. And so here we created two variables, name and age, and the values of those variables, kind of the data they point to, is David and 24. And again, the key point here, when we're creating text data, we use quotes, and when we're numeric data, we just put the number in. And so once we've created a variable, Python's going to remember that as long as we keep our browser open and we don't manually delete it. So it's consistent for that length of time, but if we close our browser or manually delete it, then we'll have to create it again. Okay, and so once we've created a variable, once we've assigned it a value, we can then use that variable in our code and Python will replace it with the value we set it to. So for example here, we create a variable favorite food, assigning it the value of pizza. And so now Python understands that favorite food is just another way of pointing to the data pizza. And so when we do print I love, and then comma to separate the inputs and favorite food, Python's going to look at the first thing and go, okay, I love, that's text data, I'll print that out. And then it looks at favorite food and it goes, okay, you've not put quotes here, so it can't be text data. If you'd have put quotes here, it would have literally printed out favorite food. But you haven't, so it must mean something else. And so then Python goes, okay, let me remember all the code that's been ran before. Okay, I remember you set favorite food to be assigned the value of pizza. And so what I'll do, I'll literally replace favorite food with pizza. And so we never see this step happening, but basically, in Python's internals, this gets replaced with print I love, comma, pizza in quotes. Python recognizes that this should be replaced by this. And so we print out I love pizza. And so that's just the explanation at the bottom here. And so the key thing to note here is we don't use quotes when we are referencing a variable. If you want, try this with quotes around favorite food, and you'll see that it literally prints out favorite underscore food. That's not what we wanted. We wanted Python to replace that with the value we set it to. Okay, so we have another set of puzzles here. So have a go at those. You can pause for a second, and then we'll join again to see the solutions in a moment. Right then, let's have a look at these solutions. So the first bit asked us to print out our name and age in this format here. So we can do that by creating two variables, one called name and one called age. So in this case, we had name set to be David. So take the value of David and assign that to the variable name. And then take the number 24 and assign that to the variable age. So now name is just kind of a name representing the data David, and age is just a name for the data 24. And so we can print out, hi, my name is, and then name, and I am age. And so because we didn't put quotes on name and age, Python's going to go, okay, those must be variables. Oh yeah, I remember you setting those to be David and 24. And so we replace those with those values. I think we also have the solution to the bonus here. We're not going to normally be doing that, but I guess we'll have a look here. So here we wanted to print out the age in 5 years' time. And so we did that just by taking age and adding 5 to it. And so if we're kind of understanding how variables work, this should make a lot of sense. When Python sees age, it goes, okay, I have this text here without quotes. It must be a variable. And so it goes, okay, what was age set to? Oh yeah, it was the value 24. And so Python literally replaces this with the number 24. And so we have 24 plus 5. Python then evaluates that to give us 29. So this literally just means, replace it with whatever value we set it to. Okay, so let's have a look at how we can manipulate a variable once we've created it. So Python will only remember the last value that we set a variable to. And so if we have hobby equals football, and then hobby equals basketball, and then print out I like to play hobby, it's going to say basketball. And so this is because the last thing we set hobby to was basketball. Like between these two lines here, Python thinks that hobby represents the value football, but as soon as we run this next line, then Python will forget the old thing and replace it with remembering the latest value. So just be aware of that. And so this act of giving a variable a new value is called overwriting or sometimes overriding. And so it's very important to pay attention to the order in which your code cells are ran. So let's give an example of that quickly. So I'm just going to create some code cells here. And we're going to do is hobby equals football. You can put that in one cell. Then hobby equals basketball. And then we're going to print out I like to play, a comma to separate the two inputs, and then hobby. So what I'm going to do now is I'm going to run them in a different order than they appear on the page. So I'm going to click play on this one first. So now hobby is set to basketball. I'm then going to run the first one. And now I'm going to print out I like to play hobby. And we'll see here that we get printed out football. And so the reason for this is that we ran this one last. It does not matter in what order things appear on the page, it's the order that we run things. So that can get a bit confusing, but thankfully, Colab has a feature to make this a bit easier to keep track of. And that is these numbers on the side here. So these represent in what order we ran our cells. So it turns out here that this cell was the 7th thing that I ran. Then this one was the 8th thing, and then this was the 9th thing. And so we can see that the last one ran relating to hobby was this one here, where hobby was set to be football. And so when we print out this cell here, we get football. If I now run basketball, this is now the 10th cell I ran, and I can print out this, and I get basketball. So be very wary of this. Like my general advice to avoid confusion is to always run things going downwards. If you want to run multiple things, say you've messed things up, you want to run everything from the start, you can use runtime run before. It's going to run everything before the cell you're currently selecting. There's a few more options there as well. So do just be aware of that. Okay, so we can also define a new variable, so create a new variable, by taking an existing one and modifying it, manipulating it in some way. So for example, we can create a variable called small number, given the value of 2, and then take small number, times that by 1,000, and use that to create big number. And so again, this shouldn't seem surprising if we understand how a variable works. When Python sees small number, it literally just replaces small number with whatever value it last remembers it being set to, which happens to be 2. So this becomes 2 times 1,000, that becomes 2,000, and so big number is 2,000. And if you go to print that out, we see that's exactly what we get. And so now is where things get a bit crazy, because we can even replace the value of a variable using an old one. So we can create a new current value by using an old one. And so this is known as overwriting or overriding a variable. I think I mentioned that before. But yeah, be careful doing this because you can end up with quite confusing code. If you're trying to do this, maybe just create a variable with a different name that might be clearer. But if you do want to do this, you can end up with code like this. So number is equal to 5, and then number is equal to number plus 1. And so if you're a mathematician, you're going to look at this and go, this makes no sense. Like this can't be. This is not what the equal symbol means. But the thing I mentioned earlier, and it's really important to iterate, is that this equal symbol is not the same equals that we know in mathematics. What it means is assign the value on the right to the name on the left. So what we're saying here is take the value on the right, the number 5, and assign that to the name number. So now number represents the data 5. And then in the second line, take what's on the right. So we have number plus 1. Python goes, okay, number, what's that? Oh yeah, I last remember you setting that to be the number 5. So I'll replace that with 5. 5 plus 1 is 6. And so now assign the value 6 to the variable number. So now number represents 6. There's no equality happening here. And actually we'll see equality later in Python. There's a different symbol for that. So a bit confusing, but do try and bear that in mind. Okay, so to follow on from that, here is a puzzle. And so we're not actually going to pause to do this. We're instead, if you're watching if you're watching on YouTube, just have a think about what you think is going to happen when we run this. But if you're in the actual teaching session, we're going to pause and we're going to put a poll in the chat, and you can put in what answer you think Y is going to give when we print it out. So have a think about that. Trying to remember, this does not mean equals. This means the left is assign the value on the right. So have a think about that and see what you think is going to be the output. And then we'll see the solution in a second. Okay, let's have a look at the solution to that. So the answer should be 2. So hopefully you came to that, but if not, it's a very reasonable mistake to make. This is a very confusing idea. So we'll break it down now and see why the answer is 2. But if you didn't get that, not a problem. It's a learning opportunity. So the explanation is here, but we'll skip that. It's very wordy. Let's do it live here. So what did we have? We had x set equal to 2. Then we have y is equal to x. And then x equals 3. And then we print out y. So let's break this down line by line and think about what value x and y has on each line. And so, yeah, I'll print this out. You'll see the answer is 2 for y. So the first line, x equals 2. So in other words, x is assigned the value of 2. So now in Python's memory, x kind of refers to the number 2 and y doesn't exist yet. So we then have this second line here. And remember, this doesn't mean equals. This means assign the value on the right to the name on the left. So the value on the right is x. Python goes, okay, x, what is that? Oh, I remember that was set to 2. So we could have just as well written y equals 2. Once Python sees this, it replaces the x with its value, and there's no relation between y and x. There's a relation between y and the value of x at that current time, which was 2. So now y is assigned the value of 2. Now we go and change x. We assign x the value of 3. That's not going to affect y, because y has no relation, no equality to x. It was just given the value that x happened to have at that time. And so y is still going to have the value of 2, and that's what we get when we print it out. So it is a confusing idea, but it also is quite a powerful idea. because it means that we have independence of our variables. They're not all going to be changed by each other. So it's quite useful. You just have to get your head around the idea. Okay, so the last thing we're going to talk about is variable types. So there's many different types of variable in Python. So we've seen some already. We've seen strings. These are text data. So we use double quotes to kind of represent these. And they're called strings because essentially kind of under the hood in Python's internals, they're represented as a string of characters. So whenever you hear the word string, you should think a string of characters, that's text data. And we use double quotes to signify that this data is a string. We've also seen integers. So these are whole numbers. We just put in a number, for example, 4. We've also kind of very briefly touched on these things called floats. And these are decimal numbers. So anything with a decimal place in it, 3.14, that is a float. And the reason they're called floats is that because, again, internally, Python is storing these using a thing called floating point arithmetic. It's a very interesting topic. You can have a look at that if you want to, just have a search for it. But we're not going to get into it in this course. And so there are many other types that we'll come across later in the course. These things called Booleans, they represent true and false, so logical values. And these kind of compound data types. So these are data types that can store other data types, but we'll get to them in future sessions. So we might want to examine what type of variable Python thinks a certain variable is by passing it as the input to the type function. And then we can wrap that in the print function to print out what the type is. And so the reason why we want to do this is that Python guesses the types of variables. So in some programming languages, more kind of lower level and more difficult languages, you have to manually say, hey, I'm creating a variable and it is an integer, or it is a float, it is a string. But Python will try and guess for you. And this is generally very convenient when it gets it right. And so it's important to be able to check what the type is, what type Python thinks it is, so that you can correct it if it's wrong. And so we're going to create 3 variables here. So days in a week is going to be set to the number 7, and pi is going to be set to the number 3.14, and greeting to the string, the text, howdy in double quotes. So the types we will be expecting are integer, float, and string. And so we can check what the type is by taking the variable, putting it inside of type. That's going to give us the type of the variable. And then we want to output that out to the user. And so we put that inside of print. So we're nesting these 2 commands. Calculate the type and print that out. And as you see, we get int for integer, float, and str for string. So those are the types we're expecting. And generally, Python will get these right, but it's good to be able to check just in case. And so it's worth mentioning, we could have also just put the number 7 in here. So what is the type of 7? That would have worked fine and given the same answer. Because when Python sees this, it replaces days in a week with whatever value it has. So essentially, the type is actually the type of the data, not the variable itself, but you can use those 2 things synonymously. They kind of mean the same thing. And so you might want to try this missing out the print statement and see what happens. You can do this in your own time. We're not going to pause for that. But you'll see something interesting happens. And you can check out the additional notes, as we have kind of extra notes listed on the course webpage. You want to learn more about that. Okay, so let's say something has the wrong type. How could we turn it into the right type? As we can do this using the functions int, float, and str. And you can see these are kind of the same names as kind of Python's internal representations, the internal names of the different types. And so these will convert any value, any variable, into whatever type is specified here. So integer, float, and string. For example, we might have a variable called string to convert with the value 10 in quotes. So this is the text 10, not the number 10. And the reason we would want to convert this is that we can't perform maths on the text 10. Like, what does it mean to add 3 to a word? It doesn't make any sense. We want to add 3 to a number. And so Python has to understand that this is the number 10 and not text. So if we print out the type of this, we see it has type of string. So we can convert this by using the int command. So use int, and inside of the brackets, we put in the thing we want to convert. So it's going to take this thing, it's going to replace that with its value, so 10 in quotes, and then convert that into an integer and assign that to string converted to integer. And now if we print out the type of string converted to integer, we see it is in fact an integer, as we would want. And so this conversion will work fine as long as it can be converted. So 10, we can convert that to an integer. There's a meaningful understanding of the string 10 as an integer. But if we take, for example, this is a string and try to convert that to an integer, we're going to get a value error. Basically Python saying, what do you want me to do here? I don't know a value, a numeric value that is the same as this is a string. And so I've been using the word function or command a few points in this presentation. So let's explain what I mean by that. So we're going to stop using the word command from now on and use function as kind of the official proper word for it. And so a function is basically a way of getting Python to do something. It's a command that has some sort of output. And so the format looks like this. So we have the function name. This is usually all lowercase using underscores for spaces, followed by a pair of brackets, and that's where we put the inputs to the function. So kind of the options for how the function should run. And so, just that, separate them all by commas. There could be none of these, one of these, two, or any number of those. So we've seen many functions so far. There is print, type, int, float, string. Those are all functions. You can tell that by the brackets here. Okay, so here is another puzzle to look at. So have a go at that, and then we'll have a look at the solution once you're back. Okay, so to wrap up this session, we'll have a look at the solutions for this set of puzzles. And so the first bit, we wanted to print out the type of these different variables here. So the first and last should seem quite obvious. This first one, that's definitely an integer, and the last one is a string, because we've used double quotes here. And so that is what we get, an integer and a string. But the middle one might provide a bit of confusion for people, because we're looking at the number here, 2.0, and as humans we know, well, this is definitely an integer. We've written it as 2.0, but that is an integer, it is a whole number. But as we mentioned before, computers are very literal and very specific. And so because we wrote 2.0, we wrote it kind of as a decimal number, Python will interpret this as a decimal, as a float. And so we see the type of it, we have a float here. So this kind of makes sense. It's kind of a very consistent thing to do, that whenever we put a decimal, we always get a float. But it might not have been what we were expecting, especially if we're new to Python. And so having the ability to check the type using this is very important. And so the next thing was what happens when we add two string variables together. And so this is kind of some intuition. We'll expand on this more in next session of why types are so important. Because we might think, I take two strings and add those together. How could that give me an answer? But Python is a very flexible language. And in a lot of cases, when you give it a problem like this, it will try and give you a sensible answer. So what it will do with two strings is it's going to concatenate them, glue them together into a single string to get something like this. So if the first, I create two variables here. The first is part one. That's going to be set to hello. And the second part is world. And I add those two together and I get hello world as a single string. So normally if we had put a comma there, we would have got a space between these. But this is just a single input now, which is hello world, no space. And so that's fine for something like this. But what if we'd had put the number 2 in quotes for this first one and the number 2 in quotes for here? And we might think, okay, 2 add 2, that should be 4. But if we printed it out here, we get 22. And the reason for that is that Python doesn't know that those were integers. If we put them in using quotes, Python will think that it's text data and then add them in the usual text way by concatenating, by gluing them together. And so if we're not paying attention to the types of our variables, we can get very strange and aberrant behaviour. So it's always worth keeping an eye on that if things are going a bit strange. So with that, we'll end today's session. Thank you for watching, and we'll see you in session 2 next week.